9:21 and 23 seconds a.m. Eastern Daylight Time, July 22, 1962, Launch Complex 12 down at Cape Canaveral. The Florida air is just hanging there, heavy with humidity, as the Atlas-Agena rocket ignites. We're talking about a 103-foot pillar of polished steel and supercooled propellant trembling on the pad right before it climbs into a sky so blue it almost looks painted.
Now, this rocket isn't just hauling metal. It's carrying America's desperate hope of touching another world before the Soviets beat us to it. Because, just a year prior, the Soviet Union had launched Venera 1 toward Venus. Sure, it failed. It ended up tumbling forever through the dark of interplanetary space. But the line was drawn. The Cold War had officially crossed the atmosphere. It's a race for the planets themselves now, and the next Soviet shot could echo for a generation.
So, sitting right on top of this rocket is Mariner 1. It's basically a 446-pound bundle of aluminum, solar panels, and gold-plated instruments. You got magnetometers, particle detectors, radiometers, all calibrated to the absolute bleeding edge of 1962 engineering. And it's all designed to answer the most ancient question we have: is there something alive beneath the clouds of Venus? Off the pad, liftoff is totally clean. Telemetry reads nominal. The contrail unspools like this perfect thread of white silk.
Let's break down the timeline. T plus 30 seconds, the roll program is complete. Beautiful. T plus 60 seconds, the vehicle punches through max Q, that's maximum aerodynamic pressure, and holds together perfectly. But then, right at T plus 90 seconds, something incredibly insidious starts to happen. Just a whisper of yaw, the rocket eases slightly northeast when it should be tracking straight due east. Down on the ground, the radar lock flickers. By T plus 120 seconds, the drift is way worse. The rocket isn't just veering anymore, it is wandering, twitching, literally jerking violently against its own guidance commands.
Imagine being in the glass booth at that exact moment. You're the range safety officer, and you have one unbearable job. You're staring at your plot board, and Mariner 1 is curving away. It's heading directly toward the North Atlantic shipping lanes, and worse, the eastern seaboard, specifically Norfolk, Virginia. A city of 300,000 souls who have absolutely no clue that a runaway rocket is bending right toward them at the speed of sound.
Up in the air, the rocket begins pitching wildly. It's a flying machine in absolute agony. The mission is officially gone. The only job left now is making sure Mariner 1's death doesn't take anyone with it. So at T plus 293 seconds, the officer turns the key. He hits destruct. 6 miles above the Atlantic, $18.5 million in 1962 dollars, which, by the way, translates to a staggering $185 million today, just dissolves into salt and steam, an absolute fortune vaporized in a silent flash.
So what went wrong? Well, a JPL review board is immediately convened. They tear apart the flight data, expecting a blown valve or a fried circuit. But what they find is actually a massive surprise. The billion-dollar hardware was completely flawless. The booster worked, the radar worked, the transponder worked. The killer wasn't metal, it was hiding in software. Actually, to be completely accurate, it was hiding in a notebook, written in human handwriting. They traced the culprit all the way back to the smoothing algorithm. This was the equation meant to average out noisy radar returns into clean velocity estimates. Somewhere in the transcription, from handwritten engineering paper to punch card code, a single mark was lost: an overline. If you're not familiar, an overline is literally just a tiny horizontal bar drawn over a symbol. It denotes time-averaged behavior. Basically, it tells the computer, hey, smooth out these instantaneous spikes into a steady, trustworthy mean. But the transcriber missed it. Maybe they dismissed it as a stray pencil mark or just totally forgot it. But think about what happens without that tiny line. The program no longer asked for a smoothed average. It demanded the raw, instantaneous value every single microsecond. So the computer took every normal, harmless tremor of electrical static in the radar and treated it like a catastrophic deviation from the flight path. It basically screamed at the booster to correct against phantoms. The booster, being obedient, swung its engines. But those corrections created real new oscillations. A fatal feedback loop tightened and tightened until the rocket literally thrashed itself to death.
Talk about a terrifying asymmetry, right? Tens of thousands of hours of brilliant engineering undone because one tired hand missed a single pencil mark. Arthur C. Clarke gave it this legendary epitaph. He called it the most expensive hyphen in history. And history remembers this because it captures the brutal, totally unforgiving precision of the machines we build. But here's the wild plot twist that emerges from the wreckage.
NASA had built the spare. Mariner 1 had an identical twin sitting right there in a hangar at the Cape.
The bereaved engineers furiously went in, corrected the code, added the missing overline, tested it endlessly, and just 5 weeks later, August 27, 1962, Mariner 2 lifted off. It climbed cleanly through the exact same blue sky, flawlessly executed the mission, and cruised for 109 days to become the very first spacecraft in human history to reach another planet.
And what it found when it got there, that's the second great surprise of this story. Because for generations, humanity had this romantic vision of Venus. We thought it was this humid, life-teeming alien jungle. But Mariner 2 transmitted back a very harsh reality. It measured a surface temperature of 900 degrees Fahrenheit. It wasn't a jungle, it was a lead-melting furnace world. That romantic dream was shattered forever by the very first probe to actually touch it.
60 years later, the rules haven't really changed. Software still flies our rockets, it drives our cars, dispenses our medicine, runs the entire modern world, and a lot of that software is still being typed out, one character at a time, by tired human hands. Somewhere right now in a midnight bedroom, a programmer is staring at a glowing screen, deciding whether or not to review a line of code just one more time. Somewhere right now, a hyphen is about to be forgotten, and the universe is patient. The universe is precise.